Alright, today's discussion is on linear equations, writing equations with parallel and perpendicular lines. And let's talk about which type of equation we are going to be using. Y is equal to mx plus b. We're talking about slope and y-intercept formula. Slope-intercept formula is what we call it. Slope-intercept formula. All right. Now, here's a problem. Let's say that we have a line. It's a line we've made up. It's an imaginary line that passes through, let's say here, negative 3, negative 2, negative 3, negative 2, and is parallel. And parallel to y is equal to 2x plus 2. Now here's our goal. Our goal is to find the slope of this made-up line and to find the y-intercept. With those two things, we're able to then recreate this line that we're thinking of, the line that passes through negative 3, negative 2, and is parallel to this equation. All right, so here's what we want to fill in the blanks. Y is equal to something x something plus something. So slope, y-intercept. Well, let's first of all talk about this one right here, 2x plus 2, the parallel line. Let's go ahead and draw it on the graph. And let's see, it's going to pass through this right here. So we know one of the lines is right, one of the points is going to be there. Let me plot the points first for this graph, and then we can draw a line through it. We know that it passes through 2 because that's our y-intercept. Notice, plus 2, and that's our y-intercept where it crosses the y-axis. And just to be clear, we know this is our y-axis and this is our x-axis. Okay? All right, the other point, let's see here. If we use slope for this line, this parallel line, is 2 over 1. 2 over 1. So we're going to go up 2 over 1, plot a point. Up 2 over 1, plot a point. We can also go down 2 over 1, plot a point. Down 2 over 1, plot a point. Okay. All right, now, with this in mind, let's draw us a straight line. Here we are. So we know this line, this parallel line, does this right here. Right there. Let me label it. We know that this line is called y is equal to 2x plus 2. All right. Now, if we have a graph, let's plot this point, negative 2, or negative 3, negative 2. Okay, that's going to be a point on, let's see, negative 3, negative 2. Right there it's going to be. Okay, and then parallel lines. What do we know about parallel lines? Parallel lines are lines that never cross. They are the one thing, they are lines that run together, but they never cross one another. So what we can say about parallel lines is that they are, let me say this, they have the exact same steepness, the exact same, they're increasing and decreasing at the exact same speed or rate. And that's the definition of slope. So we know that if this line, or this line here that crosses the point -3, -2, is parallel to this line, then it must be a line that has the exact same slope. Alright, if that's the case, then it shouldn't be that difficult to graph this line. Let's do it. Let's start here, and let's go straight up, making it parallel to the one we have right here. Let's see now. Oh, that's not parallel. Okay. That's not parallel, so that must be parallel. Well, another way to look at it is this. If we've got the exact same slope, what we could do is use this right here as our slope, or this 2 over 1. Up 2 over 1, there's a point. 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 And there's our line. Okay, so we made a parallel line. Now let's see what it is that we have. Excuse me. Let's see what it looks like in the equation format. Well, okay, we can just look at it. First of all, we know it has the same slope as this one. So let's take this slope and put it right here. 2. Okay, what else we know about it is that it crosses right here. Let me circle that. Crosses the y-axis at a +4. So we can put this right here. So here was our imaginary, our made-up line. It passes through -3, -2, and is parallel to y is equal to 2x plus 2. Well, here it is. And so the equation is y is equal to 2x plus 4. Now, this has been done by looking at the graph and graphing the line. But what if you don't have a graph? What if all you have is this point and this equation? Well, let's figure it out algebraically. Here's what we know. We know that m is equal to 2, or that's our slope. We know that slope is equal to 2 because parallel lines had the same slope. What we also know is that it passes through this point. So let's use our slope-intercept formula, or let's use this here, the blank thing that we had. We'll say y is equal to blank x plus b. b is what we don't know, doing this algebraically. So we're going to put slope in here in the place of 2, where the m is. Now we're going to use these. We know this is your x. We know this is a y. So let's put this into the equation, because this line, this made-up line that we've decided on, passes through this point. So this is a good point for this equation, and we can use it to find the variable b. So here's our x, -3. Here's our y, -2. All right, let's rewrite the equation with these new numbers. -2 is equal to 2 times -3 plus b. 2 times the -2 times the -3 is -6 equals -2, and bring down the plus b. Okay, now to solve for b, we have to move this 6 over to the other side by using the opposite sign. -6, +6, that goes to 0. What we want, bring down the b, equals -2, +6 gives you a +4. Signs are different, and so you would add the two together. -4, and that looks kind of funny, so let's fix that. There we go. So it's a +4. So our b is a +4. Now, so our new equation is y is equal to 2x, which is where we got from right there, and we replace the b with our solved for b, which is a +4. All right, well, it matches what we got when we use the graph here. All right, now that's how you do parallel. Perpendicular is a little bit different. Let's see here. Let me erase what I have. Okay. And what we're going to do is use the exact same problem. here's our equation. Here's our line. Whoops, I just messed it up. And again, this was y is equal to 2x plus 2. We want to find the line that is perpendicular. Now, perpendicular. Okay, if you've got an equation or a slope that is perpendicular, or a line, well, let's go back to this. Now, let's think here. Let's say we have a problem like -4, 2. We were looking for an imaginary line or a made-up line that passes through -4, 2 and is parallel to y is equal to 2x plus 2. Okay, what do we know about perpendicular lines? Perpendicular lines make 90-degree angles. Okay, so let's graph a line that passes through -4, 2. Where would that be? Right here, right there. -4, 2, right there, and is perpendicular to our made-up line. So it's going to do this, and a perpendicular, 90 degrees. Okay, there we are. Think that's a 90 degree right there. Oops, messed it up. Let me fix that here. There we go. Okay, we have a 90-degree angle here. Now, let's check it out. If we have a 90-degree angle, let's fill in our blanks by looking at the graph. Wrong color. Y is equal to something x plus something. Okay, let's do the slope. So we usually find 2 points. Here's a point and here's a point. So we'll use that point there. Rise over run, up 1 over 2. Up 1 over 2. We go up 1 and we're going to go over 2. So that's going to be rise over run 1 over 2. Notice it's going down, so it's a negative slope. And it crosses at right there. It's 0. So there's our equation. Now, we did that by looking at the graph. But let's do it algebraically. What if we don't have a graph to look at? All we've got is this information. Here's what we know about perpendicular lines. Their slopes are opposite and reciprocal. Opposite and reciprocal. So if you take this slope here, which is our perpendicular line, this one here, and you say 2, let's do the opposite. What's the opposite of 2? It's going to be a -2. And what's the reciprocal of -2? Well, it's a -1 over 2. Here's what you can do, just to be sure you understand it. Any whole number or regular number can be made a fraction by putting a 1 under it. And when you reciprocate that, 2 over 1, it makes it 1 over 2. Now, let's go back to our original problem. We have y is equal to, we know our slope is -1/2 x. What we don't know is the y-intercept, which is b, using it algebraically. Well, we have our point, so let's plug these in. This is our x, this is our y. We're going to put in the place of x, -4, place of y, 2. Y then is equal to -1/2, parentheses, -4, plus b. Oops, the y, that should be a 2 there. Okay, -1/2 minus 4, or times a -4, is 4 over 2, or what we could say is 2 plus b is equal to 2. Subtract 2 on both sides, and we get, it goes to 0, that goes to 0, so then b must be equal to 0, giving us the equation y is equal to -1/2 x plus 0, which is the same as will be found up there. That's how you find parallel and perpendicular lines.